Good afternoon, Carlo.
Hi, Nick.
Hello.
Hi, Firas.
Hi, Carlo.
Hi. Hi, good afternoon.
Good afternoon, everybody.
Yeah.
Let's wait a few more minutes. I see that slowly people is joining. Okay, well, we have 12 participants. I would say let us start. If others will join, I hope they will be able to catch up. So today's material is continuation of what we stopped last time. We started the analysis of a data set that includes the household hunger score and the food insecurity experience scale. So today, what I want to do is to continue the analysis, demonstrating one way in which the analysis of the data can be conducted by integrating the two tools. So as usual, I will share my screen and please let me know at any time if you cannot see well or you cannot hear my voice. So again, I will run, I hope that everyone can see the screen, and I will run the code one line at a time, commenting what is the purpose of each line. So as usual, the first lines are just to load in the libraries that are needed. And we will use Haven to load data from the SPSS format in which it has been shared with us. So the data for this session is, again, thanks to Nicholas, data collected in the Food Security and Nutrition Monitoring Survey in South Sudan. And for this session, I'm just using the round 23. And as we already commented last time, this is a data set that includes the FIES question, coded, labeled here from X01 to X08, and then the household hunger scale data, labeled from G01 to G06. And the way in which the household hunger scale have been collected is by first asking whether the experience occurred in the past 30 days, and then only if the answer was yes, followed up by a question on how often did this happen, and this can be coded as 1, 2, or 3, depending on the frequency. And the same for the two other questions related to experience of hunger and experience of going for a whole day without eating. So we can start by just selecting the FIES scale, which be achieved subsetting the column from X01 to X08. Then, because of the way in which the data have been coded, every time the answer, the response is neither 0 nor 1, we must set it as missing. So I'm achieving this with a simple line. Let's say that everyone the data is greater than 1, I put it as NA. The raw score would be obtained by summing along the rows. And in this data set, we see the vast majority of people reporting raw score 8, meaning they have responded yes to all questions. For convenience, I'm just renaming the columns with the standard names that we assign to the FIES data. So now we have a data set that is coded as we need, with only 1, 0, and NAs, meaning 0 when the answer was yes, 1 when the answer was yes, 0 when the answer was no. Now you notice that here we have a reference period of 12 months, and this is something that we need to take into account. So the traditional way of analyzing the FIES data is by running the dichotomic rush model. We do it with the command rm.weights from the rmweights package. And you will see that I'm running very, very simplified analysis. I'm not worried about the use of sampling weights or other things, because for this demonstration, I just want to guide you through the principles of the analysis. So the results that we will obtain are not results that could be considered final assessment of food insecurity based on this data. The result, as we already noted in one of the previous lectures, is that there is one item that has a slightly high INFIT, 1.39. So in principle, we should have dropped this, conduct the analysis with only 7 items. But as I said, I just want to do a demonstration of the methods. So allow me to continue by just maintaining the 8 item scale in this particular case. So far, nothing really new. Now, what is new in this data set is that this includes also the HHS data. And the HHS data can be selected by extracting the columns from G01 to G06. Now, instead of carrying on 2 columns per each experience, I am just consolidating them. And essentially what I want to achieve is merging, for example, G01 and G02, so that I will have only one variable coded with 0, 1, 2, and 3, meaning 0 corresponding to no, 1 corresponding to rarely experienced, 2 corresponding to sometimes, and 3 corresponding to often. So I just need to merge these 2 cells and then maintaining the frequency of response. There may be many ways of doing this. The way I do it, I will just replace every time the values in G01 is 0, I will put the corresponding 0 in the G02 variable. So line 22 here, initialize to 0, the records in G02 whenever G01 is 0. And I do the same for G03 and G04, and G05 and G06. And then I just preserve the 3 new compiled variables. And I am defining here now a new data set, household hunger score, maintaining only the 3 columns, which I rename run out, hungry, and whole day. And here you see these are coded from 0 to 3 possibly. There is only 1 column per each question. Again, we can compute the row score. In this case, the row score will be from 0 to 9, because each question can receive a score of 0, 1, 2, or 3. The maximum possible is if all 3 questions have been answered with often, and therefore you have 3 times 3, a score of 9. And now you will see a very already interesting comparison. We commented already last time that whereas from the point of view of the FIES, the majority of the respondents said yes to all questions, so the highest frequency is to the greatest possible row score. With the household hunger score is a different situation, in which actually the highest number of respondents have a row score 0. And then there are different numbers of respondents from row score 1 to 9. So this is already in itself evidence that the household hunger score is capturing a more severe phenomenon than what is being captured by the FIES. So let me stop 1 second. I think so far there should be no particular difficulties in following what I did. But if you have any question, please ask it now. Last time I was benefiting from Veronica, who had the kindness to speak sometimes, so I was sure that you are all hearing me. Can you please confirm, some of you, that you are hearing me well?
Yes.
Yes, sure.
Thank you. I was feeling a little bit lonely because nobody was reacting. So is everything clear so far?
Yes.
Thank you. Okay, so now this is the innovation. And what I am suggesting here is that the household hunger score data can be analyzed using a version of the Rush model that allows for the possibility that responses are scored not simply as 0, 1, but scored with a graded scale. And so in this case, we have 0, 1, 2, and 3. And the important assumption here is that we impose that frequency, in this particular case, reflects severity, meaning that a higher frequency is equivalent to higher severity, so that frequency and severity can be collapsed on the same underlying latent trait. If this assumption is correct, we can use the so-called partial credit model, which has been also is discussed in the book by Bond and Fox. So those of you who have read the book have encountered it, and has been implemented by Sara Viviani into the RM weight package through the command pc.w, which stands for partial credit. So what I simply do, I apply this command to the new matrix that I have created that contains 3 columns, each of which is codified from 0 to 3. And we can look at results, and results, as it is the case for the typical Rush model, can be analyzed in terms of item severity parameters, in-fit statistics, out-fit statistics, etc. The only difference is that now the item parameters are actually a more complicated structure, which for each question contains 3 columns. And this is because when you have a graded response, there is actually a probability of responding yes to the first severity, to the first frequency, or to the second, or to the third. So we can actually estimate a different number of thresholds. What is listed in column X2 is the threshold when, what is the probability of switching, is the severity level at which a respondent would switch from saying yes rarely to saying yes sometimes. And the last column is from saying yes sometimes to yes often. what we focus here is the first column. And the first column is what is called the Rush-Turnstone threshold, which is the one that would be comparable with a typical dichotomic Rush model threshold. This is the reason why I am selecting as a severity parameter to be associated with each item the first column, the X1 column, in the result of the PCW command. This is just to accommodate the way in which Sarah has decided to program the partial credit command. So here now, you see we have three numbers showing that the first item, which is run out, is actually a little bit more severe than the second one. And these two are somehow less severe than the third one. But of course, the numbers in this particular case are not standardized to have mean 0. And this is something that we need to take into consideration, because if now we wanted to compare the result of having estimated the household hunger score data with the result from the Rush model on the FIES, we cannot compare directly these severity parameters. So we need to conduct a calibration of the measures so that they are defined on the same unit of measures, if you wish. And one way of conducting this calibration is that assuming that the three items of the household hunger score, which I labeled run out, hungry, and whole day, are actually equivalent to the last three items of the FIES, which are also labeled hungry, run out, hungry, and whole day. So what I do now, I compute standardized values of the item parameter B, but also of the respondent parameters A, and of the standard errors of the respondent parameter. And how do I obtain the calibration? Is just by centering them so that they have a mean of 0. And I am not changing the standard deviation. So now if I do just show the mean of the standardized HHS B parameters, this is 0 because I have shifted all these measures by the average of these three numbers. And just for future reference, this scale, which is an arbitrary scale, has a standard deviation of these three severity parameters of 0.63. So what I am doing now, I am defining a reference scale that will be used for comparison, which is calibrated around the mean of the household hunger score partial credit model severity parameter, and preserves their standard deviation. So what I need to do if I want to compare, for example, the results of the FIES analysis with the result of the HHS analysis, I need to standardize the severity parameter of the FIES in the same way so that the mean and the standard deviation of the common items should be the same. And to achieve this, I just center the original scale around the mean of the last three parameters. Here this is where I'm making the assumption that the last three items, 6, 7, and 8 of the FIES are equivalent to the three items in the household hunger scale. And then in this case, I'm also standardizing by rescaling them so that now they have the same standard deviation of the three household hunger score parameters. And I have to make the same transformation to the respondent parameters and to the standard error. Now, just to demonstrate what I did, I can show what is the equivalence of these parameters. So I am plotting here the last three parameters of the FIES against the three parameters in the household hunger scale. And then I'm adding the standardized value of the FIES parameters. And so this is the equivalence between the two scales, in which, of course, the common items are the last three. As you can see, this is far from being perfect, because run out and hungry have a reversed severity order in the two scale. But the distance is not very large compared to the relative distance from the other items. And what is particularly interesting is that the whole day turns out to be quite more severe than the run out and hungry, which is a feature that is common to the FIES too. But more than this equivalence, it was important now to compare the severity associated with different row scores in the two scales. So my next chart is plotting the row score corresponding to the FIES scale and the row score corresponding to the HHS scale. And this picture should demonstrate quite clearly why the two scale, so to say, explore a different range of severity. The FIES is like having a ruler that measures relatively less severe conditions, whereas the household hunger score is an extension of the severity measurement on the severe end. Let me also pause another second, asking those of you who are understanding whether you have any question at this moment or anything is unclear. Yes, Firas, you're raising your hand.
Yeah, thank you, Carlo. Allow me to go back at the beginning of the quitting process. Maybe I missed it, but can you elaborate more about why we choose the first column of the partial credit results and not the third? And to me, the third may be more as values, more consistent with the last three items of FIES because it is positive. So again, maybe I missed it. Can you explain again? Thank you.
No, yes, I understand the question, and it's a legitimate question. The position of the columns x1, x2, x3 is not related to any consideration in terms of whether they are comparable to the dichotomic version of the Rush model or not. This is only because of a decision that has been made in coding this result into the RM weights package. Unfortunately, Sarah is not online today, otherwise she would be able to explain why she took this approach as opposed to others. But what I wanted to insist is that X1 is a different type of threshold compared to X2 and X3. And this is a feature of the partial credit model. And X1 is the threshold that represents the severity level of a respondent that has a 50% probability of switching from having said no to say yes. And for that reason is comparable in concept with the threshold of the Rush model, the dichotomic Rush model. So if I had to code, probably I would have given different names or put this set of values in different structure, reserving the name B for only the first column. But as I said, this has been a decision made by Sarah, and there are, it's as long as we know what is it, the parameters that we need to refer to, it makes no difference. Just a convention.
Thank you, Carlo.
And what we need to do whenever we apply the PCW command is to refer to the first column, the column X1, which contains the thresholds that are comparable to the dichotomic Rush model. Then, to conduct the equivalence, of course, I cannot compare numbers like minus 3.9, minus 3.6, and minus 2.75 with, let's pull out the parameter of the Rush model, the original parameter, and this would be 0.28, 0.46, and 1.47. So we cannot compare them because these are defined on different scale. Here, the average of this number is 0 by construction. Here, instead, is the average of all 9 potential thresholds that is equal to 0. So these are defined on 2 different scales. And in order to conduct the calibration, I need to bring them on the same scale as we do whenever we do a calibration. the question here is, how do I identify the equivalent, the common items? Now we are not comparing two applications of the FIES. We are comparing the FIES with the HHS. One assumption is that there is full equivalence between the 3 items of the HHS and the last 3 items of the FIES. So I'm imposing that these are the common items, and therefore calibration amounts to ensure that the common items have the same mean and the same standard deviation, which is what I have achieved by doing this rescaling. And the result is that the raw score 0 on the household hunger scale is equivalent to more or less raw score 2 or 3 in the FIES. And even raw score 8 in the FIES is equivalent to only a raw score 3 or 4 on the household hunger scale. But this is exactly the reason why the household hunger scale was developed, to be able to discriminate better around more severe conditions. And now let me show you one problem that we have with the data, the way in which it was collected in South Sudan, is that there was no attempt at imposing some coherence between the household hunger scale and the FIES. They were asked as 2 separate modules. And this means that maybe there is some inconsistency. And in fact, if we try to see the distribution of response of, for example, the run-out item in the FIES and the run-out item in the household hunger score, we see that there is a small number of cases in which people responded would have said no. This is the run out of food. So let's go back to the actual question. The actual question was, during the last 12 months, was there a time when your household ran out of food because of lack of money? And then there are 259 people who said no to this question, but they said yes to the question, in the past 4 weeks, was there ever no food to eat of any kind in your house because of lack of resources to get food? And actually, 259 people said yes, rarely. 46 people said yes, sometimes. And 2 people said yes, often. Now, these are not big numbers, but in a precise way,